Hey, if you're seeing this, you've made it to Bat Appreciation Day. Whether that's an actual holiday depends on who you ask, but if you ask Bat Conservation International, it is. I've been looking at Steam, where the developers of Against the Storm have added bats to their game. And of course, I've got a lot of videos, some of which involve bats, some of which involve kobolds, some of which involve useful eyeballs that look at you and tell you encouraging things. But of course, aside from that, I've been editing the thumbnails of my other videos. I've been receiving advice from God on Signal, and I've been working on programs. Now, you're going to see a program from me in a moment. You're not going to see it yet because I haven't written it yet, but we're going to start right now, and we're going to start in Python. This is a program whose utility will become obvious now that you've seen what it is that's going on the rest of my computer. We'll start a little bit by writing a main module, which every Python program has. Despite the fact that I use a lot of strange programming languages in these videos, I have to admit that I probably write more Python than anything else. It's the primary language that I use at work, and it's also the primary language that I used for personal projects during the periods when I wasn't using Haskell and Prolog for those things. I never really got good at Prolog, although I think I'd be comfortable saying I got good at Haskell. But I think I'd genuinely say that I'm pretty good at Python. Usually when you write a Python program, usually when I write a Python program, I like to make sure the environment is actually working the way that it's supposed to. You'll be able to see that I've got a terminal here, and a terminal is useful. So if our Python environment is configured correctly, then this... Oh, thanks Windows. I don't know if you heard that, but there was a beep. We want to go to the Python folder and we want to try that. There, that's beautiful. So the program we're going to write today is a program that does something that Python is not innately good at. It's a program that talks to Windows directly. I would say that in general, Python's good for a lot of things, but one of the things that it's not good at is like low-level memory hacking, and we're going to see that abundantly. I shouldn't say low-level memory hacking. I should say anything that depends on the exact representation of data types is difficult for Python. What I do want to show you is that Python's good at something that you may have heard about in school or you may have even used at work, which is called object-oriented programming, which is a particular way of structuring programs. So to start with, I'm going to write a program that manipulates the mouse. Windows has the ability to tell you things about the position of the mouse that you might be able to use in the rest of your program. And to do that, you call the functions for this that are defined in user32, which is one of the main libraries included with the operating system. We would say that they basically have privileged access to operating system features. The reason that I want to interact with the mouse is that I want to move it around and I want to read its position. And that's going to be part of the program that we write, which is going to animate the mouse without the user's direct interaction. The Python tooling that's built into Visual Studio Code is pretty decent. You can do things like obtaining types from this package that defines a whole bunch of them. You'll notice that this is a ctypes.structure, which is different from a class. This is actually the Python representation of a data structure that was originally defined in C. Somebody actually presumably had to write this, possibly even from scratch, because these types are only exposed in C in a way that C can understand. They're not exposed in a way that Python could innately understand. Python does go through a library called libffi, which actually does the work of wiring Python up to C, and it's exactly the same library that Prolog uses for this purpose. But Python, of course, despite having access to the dynamic definitions of C code, which is to say the runtime shape of the C code, Python actually, that's not entirely true. Python has access to the runtime shape and the compile time preserved information about the C code. It doesn't have access to the kinds of things that only exist in header files. And if that goes over your head, learn some C and maybe it won't go over your head. So we have the ability to see where the mouse is now, or at least in theory we do. I haven't actually named this variable right, so that's no help at all. One of the things that we can do and definitely should do is make sure that, here it is. LP point, by the way, is how Windows spells pointer to point. It's, in fact, literally defined that way. So a pointer is basically a a name for a site that can be used to assign to it externally. When we call byref, we're giving Windows a reference to this point such that Windows can make changes to it. So one of the things I can do right away is I can show off where the mouse is. And you can see that these values, which look arbitrary, in fact correspond to positions on my screen. If I go to the very bottom, we'll see that it's that value. If we go to the very top, we'll see that the Y goes all the way up to 0, and it could be anywhere in between. So that works correctly. This is just Cartesian geometry. You've probably seen Cartesian geometry before. There's also a function that does the opposite of what I've just done. And whenever I refer to one of these by names, or by name, C-types will go ahead and find it. Oh, hold up, that's not the right function. This is the right function. You'll notice this actually isn't the int that comes with Python. This is the int that comes from Windows. So int is a specific data type, and it has I want to say it has an unknown size. I think its size might actually be equal to 32 bits, but it might be 64 bits. I'm not sure offhand. In the 64-bit calling convention, the first 6 arguments of a function are going to be passed as 64-bit integers anyway, so chances are, even if I got this wrong, it would probably still work fine. Anyway, I can wrap this with a slightly friendlier wrapper, which would look like this. Right. So if I want to move the mouse to the top corner of the screen, I can simply do this, and it doesn't work. Oh, because this has to be a tuple. Useful. We have the ability to put Python on strict type checking mode for what it's worth. So if Python is in strict type checking mode, we're going to get an enormous amount of type or help from the linter program Pylance, which is Microsoft's branding of Pyrite, if I remember right. Pyrite being this really popular type checking program that I think is built in-house at Microsoft. That sounds true to me. So anyway, we do have the ability to move the mouse, and possibly that's useful. There's one other bit of information that I'd like to obtain from Windows. This is a function, if you look at MSDN, and I'm going to, I'll plot MSDN for you. Yeah. I've bookmarked all kinds of things, actually. I believe that this is a restaurant. No, this is... Why have I bookmarked a restaurant in Florida? Is that useful information? I have bookmarked what appears to be a mediocre sushi bar in Florida. Interesting. I must have had some reason to do that. Anyway, this is a function where Microsoft has just dumped every conceivable numerical value that exists in Windows, but particularly the ones related to drawing the screen. There's a particular variable from the endless and seemingly pointless list of variables that I specifically want to get out of the API, which is the vertical resolution of the screen. So that variable name might seem cryptic. That is the actual name from the header file. As I've mentioned, libffi can't actually read the header file because the header file is destroyed as a part of C compilation. There's not really a way to get it back. There are languages that can read the header file, and to do that, you need to actually have the header file somewhere on your computer, and then they'll just kind of munge it together at runtime. I admittedly have never used a language that has this behavior, so I don't know how well it works, if it works at all. Right, so we can see that it correctly reports the vertical resolution of my screen as being 1,152 pixels. So we're now going to create a mouse class. This represents the mouse in a more explicit way, and it exerts some control of the mouse. So normally when you move the mouse on a computer, the movement is instantaneous. There's no velocity. Well, there's a velocity in the sense that there's a displacement per second that comes entirely from your movement. But I mean there's no persistence of the velocity. The velocity is just whatever movement you exert on the mouse during any particular time step. So we're going to we're going to track a velocity really fast. So res y, as you'll remember, is the resolution of our entire screen. So we're going to then make some rules. We'll start by getting the x and y of the mouse, which we can explicitly say are a tuple of integers. Already, yeah, so strict mode is, in fact, really strict. It's complaining that we never access this. That's entirely true, and it's a valid criticism of the code. So we'll say that we'll do this very simply at first. Oh, right, this is a tuple, so we've got to remember to do that. So what we will now do is we'll create this loop. We'll update at 120 FPS. Now, you're watching this at 30 FPS, assuming I haven't done something that I don't realize that I've done. Right, we've got to... Foolish of me not to do that. So this will run at 120 FPS, give or take. So the effect of all this code is that the mouse slowly falls to the bottom of the screen. We might want the mouse to fall quickly to the bottom of the screen instead of slowly. So what we'll do... Oh, I've knocked over an object. I've moved the object now. Apologies, I was drinking something earlier and the empty bottle is just sitting on my desk. We will say that if the y has exceeded the vertical resolution of the screen, and assuming that the object is still going down, we'll helpfully have the mouse veer upwards instead. So if the velocity is negative, we're going upwards instead of downwards. And now the mouse has this nice little bounce. And I can make sure that you actually see it. Yes, the mouse is visible on the screen. Useful. Beautiful. So we've got the ability for the mouse to bounce. There's a few other behaviors that I specifically want to deal with. One is that sometimes the last few bounces on that mouse can be highly visible. So we're going to suppress the last few bounces. This is just a general rule that if you have a program that can map a very small difference to a visually large difference. Oh, wow, it's still going. Wow, it's really going. Yeah, we might have to do more about that. But yeah, if you have a program that can map a visually small difference to a visually large difference, like let's say the floating point value 0.01 can be the difference between 0 and 1 pixels, you often want to impose some kind of threshold like this. Just so that like the system goes into a quiescent state instead of like visibly vibrating. One of the things we can actually do is we can track, instead of just tracking the velocity, we can also track the offset. That is the floating point difference between the charted position, which is an integer, and the achieved position, which is, and the desired position, which is a float. So like we're moving it to this integral position right here. So now we actually don't update x at this time, and it's possible that we might later. But for now, we'll just keep it symmetrical, even though x is always going to be equal to the thing that it was equal to before. So we'll then say that yes. So now we're tracking the offset between frames of the mouse. Yeah, that deals with the bounce nicely. Because previously what was happening is that it was teleporting to the very top of the pixel. It effectively always had this last offset of 0, 0. So while it was on the bounce up, basically any upwards velocity would result in y decreasing. So like, for instance, if the upwards velocity were, if you had all these decimal places, well, if you were to subtract that from 0, then all of a sudden you have a number that rounds down to, actually it would be easier to do this from 10. So if you have this number, that equals 9 point, I guess it would be a bunch of 9s and then a 5, something like that. So since we're rounding down here, effectively that immediately results in a teleport upwards to 9, which all of that is to say the code didn't deal well with extremely small values before. Yeah. We can probably do a little bit more with this. One of the things that I notice is, and these are all constants that I set by feel while I was testing earlier, which is to say that some of them might not make sense with the shorter time step. We're now doing a bunch of very small updates in a single tick. We're doing 100 of these tiny updates in a single tick. And there, we've got that nice bounce. Well, maybe it's that nice bounce. Depends on how you feel about it, I guess. So our mouse is looking pretty bouncy. But the thing that we could do is we could actually make other stuff bounce too. And that gets into the other thought that I had in this whole presentation. And the thought that I specifically had is that we could do windows instead of just the mouse. So this gets into object-oriented programming. We want to model the mouse in a way that is consistent with only the parts of its movement that are unique to the mouse. The mouse bounces the same way as everything else. It is only its position that is distinguished from other objects. So this is also the mouse. It's not actually the mouse because, as you can see, none of this functionality is provided. All of this functionality is provided only in this totally theoretical way because I haven't implemented the interface. So this gets us a new definition of mouse, which is only concerned with these functions that we've written already. Note that we could write these functions for any object, including an object that has no presence whatsoever on the screen. We could implement it totally correctly for such a thing. For instance, if I wanted to represent an imaginary cube inside of a video game world that isn't a window inside of Windows, you could just as easily apply this same interface to it. Oh, what's wrong with it now? Oh, I've defined this twice. Yes, we'll take this common logic, we will call it body, and we'll do some refactors like this. So having done that, all of this unique mouse-specific logic has been moved away, or at least it certainly appears to be. Right, that looks pretty good, or at least I think it looks okay. So what actually changes? Oh, for one thing, this is apparently, oh, this is busted? Wow, didn't know this was busted. I disagree with, I guess it's unknown because, what? Why does getting rid of that get rid of this error? Wow, that's incredibly mysterious. Okay, well, I'll ignore it for now. When I'm oh, wait, now there's a parse error? Oh, wow. I've made a bunch of small mistakes in this program that appear to have confused the heck out of Pylance. I guess some of this is the virtues of strict mode, which is that strict mode is fantastically arbitrary in what it considers to be reasonable. Like, I can see part of the problem. Part of the problem is that we've done this refactor, and now we actually have to rely on the... Oh, I see. Removing time fixed it because it introduced several other bugs throughout the rest of the file. That'd explain it. Maybe that's better? Thank you, Pylance. Apologies. I'm feeling very clumsy today, I think, is how I feel. So because we've been able to implement only these unique parts of mouse, we can now do window exactly as I said that we were going to do it. So usually when I implement a class, I tend to start with the abstract method declarations, and I tend to convert them just like this. So there are functions inside user32.dll that can help us just as before. That's right, Windows do have a handle that they're associated with. Oh, no need to write it like that. The actual type, by the way, that's correct for this, so maybe we'll use this type. It'll be mapped to a Python int, but just for the record, it is a hund, which is a handle, which is a... Wait. Actually, hold up. It's interesting that this gets mapped to an int in Python. I know that it does. I've tested that. But the type that is represented as C types is very different. I actually wonder if perhaps this isn't a type token, although it certainly is treated as one. Python seems to think that it counts as one. Well, what's C void P defined as? It's certainly not defined as an integer. Also, I see that Pylance doesn't like the Python standard library, which I assume is an indicator of strict mode, but might also just be an indicator of the general lack of adoption of Python typing, even though it's adopted enough to be very useful. I don't know, Python is weird like that. So once we've done this, we know the position of the bottom left corner, which is the value that we care about for the purpose of bouncing. We only bounce on the bottom, not the top of the screen, so we don't care about the top corner at all. We can then, oh, and this is going to be alarmingly verbose. We'll go with verbose. We want to figure out where the window was. Actually, we don't need the width. The handle is basically the name of the window according to Windows. Every window gets one. It is unique to that window. I can't remember if they're allowed to be reused. I assume they're not. I'm not sure offhand. So this convention, which is somewhat intimidating looking, Windows has this set Windows pause function, which is of course what I'm using to move the window around the screen. The set window pause function takes a set of flags, which are each represented as single bits in a large hexadecimal number. And the default behavior of set window pause is to activate the window, resize it, and move it to whatever position you present. This is probably not what you want if you're moving windows that you don't intend to directly interact with. So we are telling Windows, don't make the window active, don't resize it, don't change the order of the window relative to other windows in the overall stack of windows that exists. And this one's more subtle, and I'm not actually sure if it works correctly because it didn't make any performance difference in my testing. We tell it to let the owner of the window handle the move by pushing the move window action or event or whatever they call it in Windows API to the thread of whoever controls the window. I think I straight up do not understand how this one is supposed to work. It makes absolutely no difference in my testing, even though it feels like it should make some kind of a difference. So what do I know? Anyway, we have the ability to control a window now, but we don't actually have the ability to get the windows, which is, of course, necessary if we're going to control them. So we're going to make this object which owns them. We always know that we can create a body for the mouse because there's always a mouse on Windows. It would be weird not to have one. Actually, I'll go with a slightly better name. So the gist is that we're going to use this function that I haven't written yet to get a list of all the windows that there are. And then we're going to either reuse the body if the window existed the previous time that we enumerated the windows, or we're going to make a new body for the window. And maybe that's better. I can, of course, I can fix all of the many errors in the code that I've written without meaning to. We're not going to be able to fix this yet because I haven't written the function that actually gets the list of windows. I've fortunately got that lying around somewhere too. So Windows has a particular convention for going through lists of things, which is that you present Windows with a function that it's going to call for each of those things in succession. It's going to be tricky to type this, so we'll write it with the wrong type first, and then I'll fix the type in a moment. We only care about visible windows. Right, so Windows is going to call this function for every window that actually exists. The window is going to be converted into an integer for Python's benefit, as will the lparam, which is Windows' word for a parameter that is, I believe, the size of a void pointer that can be anything, but is usually a pointer to some kind of data structure. In this case, we're able to actually pass a function to enum windows without passing a pointer to the resources that the function uses, because libffi does magic that I don't fully understand. So we've got a few more functions to define here, and we've also got to write the prototype for the enumerate windows callback. So this says that it's a Windows function that returns bool. It takes a window handle, and it takes a parameter of void pointer resize, all of which is true. We'll say that we put one of those into the enumerate windows function. And again, the only reason that we have to write this stuff is because Python cannot see into the C header files, which is where this information is all defined. We'll prototype all the other stuff while we're at it. As you've noticed, lprect is how Windows spells pointer to rect. That is the general Windows naming convention for types. This is, of course, a very specific type. Many of these ints, it's something like window, x, y, width, height, and I don't know, color. It's not color. It is, oh, window, previous window, x, y, width, height, flags. That's the order of those parameters. I think most people would be confused by that, though. Yep. Is window visible takes a window handle. We know that to be true. And okay, pylance, I think I'm going to have to just take pylance out of strict mode because while I could probably appease it, I can't appease it in any reasonable way. This is probably not code that pylance can easily be satisfied with the correctness of. So we have this enumerate windows function. It gives you an int for each of these. Window apparently would, oh, I still have that defined as taking a window handle, which, well, that is somewhat more correct. The actual runtime type we get is an int, and Python's type system seems to be weirdly at odds with the actual interface of C types for reasons that I suspect somebody other than me would know. But unfortunately, I can't speak for such a person. We'll actually do this inside the loop because in theory, somebody might change their resolution, though in practice, I'm guessing they wouldn't. So we have this list of bodies. We're going to update it every tick. And then for each of those bodies, we're going to update it. Oh, I didn't actually make a getter for this. Foolish. Yep, just assume it'll take me a few tries to get any function right. We'll close the file that makes Pylance miserable, because Pylance doesn't need to think about that. And yeah, there's a non-zero chance that this will just work. So we'll make this a little bit smaller. We'll artfully arrange our windows so that the windows are not stomping on each other. We'll make my beautiful video thumbnail a little bit smaller than that. We'll move signal. Oh, signal will... Beautiful signal. I hope you like being blessed. Oh, so Signal is a program that seems to like to maximize itself every time you change its size or position. That's pretty cool. And oh, did I lose Dragon Sweeper? Oh, I gotta... Wow, that's loud. Yeah, jump scare of the day. Jeez. Now we will... Ah, that's the stuff. There. We can see what we did. We've got handle window. CB enum windows, that's what I think I named it. Takes 8 arguments? Well, excuse me. Does it really take 8 arguments, or did I just type the number of arguments wrong? Because it wouldn't surprise... Let's just try it with the wrong number. There we go. That's what I like to see. And we can, of course, open the run menu, which doesn't really help, does it? That part's fine. You'll notice that it's really hard for us to get the mouse to move. The mouse is resisting us. Oh, these windows are just slowly falling through the floor. They shouldn't do that. Let's see. Okay, I got my mouse back. Yeah, so we do have this falling through the floor problem. I think one of the ways we can deal with this is by making the window refuse to be updated beyond the... Actually, we shouldn't have to make the window do this. We'll just say that... Yeah, something like that. Now, this program has an interesting property, which is that it does rely on whether the window is visible. I believe that it saves some cycles on windows that aren't. Anyway, that'll do for now. So, by now you've probably seen the title of this video. In the video, I assert that such a program as this might actually be easier to write in C than in Python, which I had initially thought was true, and I've actually concluded that it's not easier. It's actually very similar, and the resulting program is fairly similar too. It's just very different. If it makes a difference to you, the program is a little bit longer. One of the things that I'll be showing you when I write this C too is that C doesn't like object-oriented programming, and there's some really big differences in how we have to structure the program in order for it to be neat in C. Anyway, to start with, so there are tools for C and C++ programming that come with Visual Studio Code, and I will be using their I'll be using their editor plugin, which provides helpful suggestions, but I actually hate the process of invoking their compiler. It does things like displaying C errors as alert-style message boxes, like the ones you see in JavaScript. It dumps a lot of files into your project directory without asking you if you want them, including VS Code settings files, which I find to be really obtrusive. And in general, I don't like the experience of working with it. I find it to be really, really obtrusive. So I'm using Zig as my compiler. Zig is, of course, a programming language of its own, and it's actually very suited for this task. But I'm probably not going to do the same program in Zig because I don't really know Zig well enough to do a fast job, and I've already done this in C, so I know how to do it. We'll pull in a few dependencies. These are going to be the same for a lot of programs, with a few notable exceptions. Most C programs don't actually need math.h. It's if you're doing math, you need it, but if you're not, you wouldn't pull it in. I was using time.h earlier to do some benchmarking. There's a function called clock in there that's really useful. One of the things that you do in C is you decide how large you want your data structures to be up front, because then you don't have to spend any time or effort resizing them. So that's a thing that's worth considering. Not everybody will use this pattern because there's nothing stopping you from making your buffers larger every time you need to. Nothing's forcing you to do this. But in my opinion, it is considered appropriate style and it is generally good to do it. Now, the other thing I want to point out, and this is, I think, the biggest difference between the Python and C, if you were to draw a quick diagram of this program, it would look something like this. You have mouse, you have window, and referencing both of these is body. So body is a concrete class that can hold two implementations of an abstract thing. This is the exact opposite of the order in which you do things in C. In C, you typically have the more abstract elements of your program, the parts with more implementations, hold on to instances of the more concrete things. So we can actually translate. Let's look at the exact type because I don't want to translate it wrong. We can translate body pretty close to exactly, except for the fact that this controlled object field is not something that we can have. This is, by the way, the convention for defining a data type in C, in case you've never seen C. This is roughly equivalent to writing class body T. Actually, no, we don't need that. We don't need to track where it was. We would if we were doing something other than what we're doing, but we're kind of not. Unless I'm sorely mistaken. Yeah, we're only tracking the offset. Cool. So this is what you write instead of a constructor function in C. This says, give me a body T that hasn't been initialized, and I will help you by initializing it. So this is, of course, the exact same. We've written just that, but we've written it in standard C style. One thing we can do to make this a little bit easier to read, by the way, is we can put this comment in that, color codes our file for us. So we're going to write this in a somewhat unusual style. We're going to say, give me a copy of X, give me a copy of Y, and then I will write you a new one. I say this is an unusual style because often you would just take a pointer to X and Y directly. And I suppose that there's no deep reason to do it this way. There's no direct analogy here because in this case, X and Y are pulled out of control object, whereas in this case, controlled object will actually be calling this function. There's no strong reason to have it be this convention of taking a copy. There's no reason that we couldn't, for instance, write it like this. So this would be equivalent because we would just, we would pass the pointer to where we want it to go. And if somebody objected to this design, they could make the copy on their side and then call. In fact, I think I've convinced myself that I prefer this design. And I think this is what I would expect to see more in somebody else's C code, just personally. So what we'll say is, and we'll put this on the screen too, just so that we can compare these more exactly. We're going to compute a floating point version of X, which In Python, we use the same variable for this because Python allows you to reassign a variable such that it has a new type. And in fact, we've now done that. X goes from being an int to a float, which is, I think, an odd thing to allow in your language, but I understand the convenience. I've obviously taken advantage of it even now. So this is, of course, the exact same as this calculation. We can do the same time step thing. Right, so that'll do 100 steps of whatever loop we like. Yes. So we haven't actually defined res_y, and we do get the expected error. We'll do that in a moment. Like, the code almost writes itself, right? Like, it's very similar. One thing that we will do differently is we actually know that the velocity is negative at this point because we've just flipped it. So we can actually write the absolute value check like this. It doesn't truly matter if we do this. Like, presumably any smart compiler is going to know this anyway because it doesn't take that much effort to prove it. Although I haven't tested the compiler. Maybe the compiler isn't smart enough to know that. But I prefer that just because the default absolute value function in C is only defined on integers. So it would actually be, there's probably a floating point one that I don't know about, but like when I'm reaching for floating point functions in C, I tend to think this isn't what I want to do with my life. So at this point, we know what the values are. And just as before, we can use this information to determine what the difference is. We won't be calling set position because that has multiple implementations, so the caller will be deciding how to do that with our new value that we've made, and we'll have concrete examples of that shortly. But we will populate these values because this logic is always the same. Yes, I personally find this much tidier than the Python code, by the way. I think that the consistent data types everywhere are just much easier to understand. I would greatly prefer to read this code. That's just me. Anyway, we'll also have... Now, in Python, we do this every frame. We could, in theory, do this every frame, or we could only do this once. I've named this update because I want to do it every frame. Typically, you will name one of your functions something like init and one of the functions something like update or handle step or something like that. You'll remember this really strange variable name that I had to define earlier. This is, of course, actually defined now because it's in windows.h. I mentioned that Python can't reach in, and what I mean is that like the first stage in C is that you take all of these defines and you get rid of them. So when you've written a define in C code, the output code will not contain, it literally will not contain this text because it was substituted out. Now, I assume there's C compilers that would really like to help you and they will somehow preserve it for you, but I don't know how such a thing works, if it even exists. So I think it's just safer to assume that no vestige of this exists, and certainly no vestige that Python would be able to understand. Anyway, we've defined body update. We can do a little bit better now. We can do our implementation for the mouse, and you'll see very clearly what I mean now when I say that the more abstract thing holds on to the less abstract thing in C. C doesn't have methods. There's no way that body could locate an implementation of get position or set position for mouse because very literally the mouse doesn't have a type tag or a vtable or any structure that could be used for that. So this results in the pattern of each relatively abstract thing getting its own collection of typically global variables. Sometimes these are just variables inside some structure, but very often they're global. So we have exactly one mouse. It is global. It's not distinguished from the body. It's only distinguished by a new type, basically as a matter of convention. One of the common things that you do in C is you'd use a header file to hide the fact that this is actually just a body T. That is slightly trickier than you would expect it to be, just because when you advertise a type, if you want somebody else to put that type on their stack in C, which is to say, if you want anybody else to be able to declare a variable of mouse body T, they have to at least know how big it is and what the layout is. The most common pattern for dealing with this is that I might define something like I actually forget the exact way that people represent this, but this is an option. So this might be how you write it in the header file, and inside the implementation, you might do something like this. I'm sure I haven't gotten exactly the pattern. I'm sure there's something somewhat wrong with the example that I've just written, but that's the idea of the pattern. It's been a really long time since I've written much C. I actually haven't written much of it since I was in school. So you'll probably see various things that shock and amuse you. That being said, I think I'm close. So we will say that x equals, we'll do it like this actually. Actually, there's an even simpler way to do it if you want to see something mildly confusing. So everybody's playing along. We are relying on the fact that the fields of x, y have a type that is compatible with body update. Actually, I think that's a bad assumption. Like, a long and an int32t are not the same. So we'll do it the less clever way just because I don't trust C, which I think is the running consensus on C, is that you shouldn't trust it. Yeah, so at this point that's all been updated. We'll do Windows in a moment, but first we will quickly write our main function. This is another Windows API function, by the way. There's a different way to do this on POSIX, and I don't remember what it is. This will give us a chance to see run.batwork too. Oh, and the mouse just... Wow, there's a lot of gravity on the mouse, actually. I feel like I must have gotten some logic wrong. There's so much gravity on the mouse, actually. And it's not bouncing. Okay, yeah, there's something wrong with the logic here. That's good. We get a chance to fix it. So most obvious difference is here. Let's see it fail to bounce one more time. Let's get rid of this block. Yeah, so that's not the problem, apparently. Very interesting. That should bounce even more simply, and it sure doesn't. So at this point, my guess is that the resolution is not being computed correctly. Yep. I think that would have this behavior. Now, unfortunately, in C, debugging is obnoxious. We'll go with obnoxious. So the most obvious question I think to ask is, what actually is being populated into that? Now, the zoo of formatting codes in C, who even knows what they are? There's a lot of them. So I'm going to quickly, I just want to see if the mouse stops at a different, oh, okay, it does bounce then. Interesting. We'll try it from a higher place on the screen. Interesting. So it does seem to bounce in that particular condition, but it doesn't bounce in this main condition. And if I even subtract 16 from that, interesting. In that world, it does bounce. So what am I doing wrong? Do I have it? Am I moving it by the bottom instead of by the top? Because I feel like that would have the effect that I want. Like, the cursor's a few pixels tall, right? Let's look real close at how the Python code behaves, because I have a feeling there's a problem there too. Let's quickly, for that matter, was it even doing the mouse? I might have gotten so entranced by the windows that I forgot to check if it was doing the mouse. It is doing the mouse, and it's doing a pretty good job with the mouse. Sorry, I'm gonna try random things a little bit more, and then I'm going to be more systematic about this. Unfortunately, nobody likes debugging in the middle of a video. Or at least, well, you might like it. I find it very stressful because I don't know how long I'll be doing it. I don't even know if that's the formatting code for a float in C. I sure hope it is. So, okay, what that tells me is that... Right, that's it. Yep, so we were checking against the original version of Y. That was a too literal translation of the Python. See? Figured it out eventually. And this is right after I praised the structure of that code for being so much prettier than the structure of the other code. Which I guess goes to show that just because it's prettier doesn't mean it's not wrong. So we do still want to do windows, and we want to do them the exact same way we do the mouse. And this will give a chance to show off a few more other common C patterns. I want to continue to emphasize, by the way, that like the Microsoft header files give us a lot of help with this. So this is actually an array of structures, and you'd commonly see a different way of laying these out, where you'd have one array of windows and one array of bodies. And there's nothing wrong with that. In fact, I might do that for now, just for the fun of it. Look, no, I'll stick to this pattern. Actually, it's simpler. One thing that you'll see is that when somebody builds a collection every frame, you'll often see them keep the future collection lying around. just in case they need it. This means that I don't have to allocate a new collection every time I want to build a list of windows. In case I've lost you, we'll look at the structure here. You'll see that I create the new list every time I start this right inside of enumerate. And maybe that's not desirable. Like, maybe we don't want to have to pay the cost to do this and to eventually get rid of the old value of self.windows every time. This is something that probably doesn't matter in a program of this scale, and indeed there's going to be some inefficiencies here that are so obvious that even somebody who doesn't know C would probably see them. But this is something that sometimes comes up when people are designing larger programs. We currently set a limit on the number of windows we would consider. That limit is still true. So we now have room to store max windows in terms of window body T's twice over, which we probably do indeed want to do. We don't need to separately prototype this in C. C has no ability to do any runtime casting of this. I mean, it'll gleefully turn this into a void pointer, which can be used anywhere, but it's not going to do anything intelligent with any runtime information. So the gist of this function is that it's going to dump an entry into new windows for every window that is seen by enum windows, which we will be calling shortly. It returns false, which is represented in this case by the value 0. You can also write false, but that's a relatively recent addition to C, if I remember right, and I am not in the habit of using it. So what we'll do is, if we've run out of space, we will say, don't give me any more windows. If the window isn't visible, we will say, sure, give me some more windows, but we won't actually use it because it's not visible. We'll now build the new body, and to start with, we'll build it as if we know that this window needs a new body. Now, if that window already existed, we'll steal the old body from the old collection. Now, this is quadratic, and that's not good, but the number of things in practice is like 50. And whenever you can solve a problem using only arrays, that's usually a good solution. In practice, scanning a tiny collection like this and linearly searching for a value is usually pretty fast anyway, just because there's no room for it to be slow. The entire thing can be done in cache. Of course, realistically, this isn't the bottleneck of the program. The bottleneck is that WinAPI isn't very fast. At any rate, the effect of this is that after this is called for every window, new windows will contain a full list of the windows. So we'll now swap the collections, because remember, we did our big pre-allocation. Presumably, remember, I talked about it very much. So we'll use the new collection, which was lying around. We'll set this one up for the next iteration. And we will write. Okay, fantastic. So yes, and those collections are all initialized how we want them to be. We should be good now to implement the same logic, but for Windows. Something you'll notice is that we don't define any generic getter functions in this program. It's not that we couldn't, it wouldn't be hard to do so. It's just that we know that they're only ever called in one place, and there's really no need to. So it's nice to avoid it. One of the things that we can actually do is that we can avoid a specific problem with the design of the Python code, which is that get_window_rect is called twice. Because we're encapsulating it in such a way that the more abstract thing, and in this case the API, the thing that calls WinAPI directly is more external, it has more control of its use pattern, and we can actually elide one of the calls to get_window_rect. This is one of the benefits that people are referring to when they say that they want you to use data-oriented design, which is a word that I keep using without really defining. And I think that the best way to understand it is that it is this broad category of C techniques that involve looking at the most specific usage patterns and trying to design your program bottom up based on what they cause your program to be like. I think that there's certainly much more prescriptive advice that you can get from watching videos on data-oriented design that have that in the name. It's kind of a weird niche because I feel like there's a lot of weird masculinity bullshit tied up in the advocacy for the patterns, but like the patterns are really cool. Probably the most recurring pattern is that like if you can use an array to do the thing, you definitely should. Like that definitely comes up pretty often when people decide that they're going to brand their advice as data-oriented design. Anyway, we can at least concede that it's like extremely different from the OOP that was used in the Python version of this program, and maybe that by itself is cool. We can refer to all of these by their actual names instead of just commenting them. Although again, I'm not entirely sure that async window pause actually does anything. So we can now throw in a window update here. And this can just be the same as before, or at least reasonably close. Now we'll see, there's a chance that this even works. I'll check OBS to make sure. Yeah, OBS is still feeling pretty good. And, oh, it crashes. Well, that wasn't supposed to happen. It crashes without an error message too, which is usually that means that you've done a really, oh, I see, we never actually allocated the structures. The crashing without an error message is one of the things that I really hate about C. So we'll terminate that. We've got, I think we have an extra case for this in Python. Do we? Yeah, that's right. I almost missed this. Well, hold up. Now I've lost it completely. Offset Y. There. That's the stuff. And here it is. Yes, that should keep things from falling through the floor. It sure does. Fantastic. Now, I happen to think that this program feels simpler in many ways. In practice, it's a little bit longer, and as you can see, it wasn't easy to debug. There's obvious ways we can juice this to be shorter. We can literally delete a little code. So there's one other thing that I want to point out as a refactor that is easy to do in this design. It is possible to do this refactor, but it is a much less local refactor in Python. One of the things we can observe, and we can do so by starting from the definition of body update, is that X never actually gets updated, ever. So we don't need to track that. We don't need to track that either. We don't need to track that, and we don't need to track that. So now we've created a problem that in an ideal world would actually create a compile error in the rest of the program. We'll look at the rest of the program and see why the compiler isn't complaining, because it should be. Oh, well, Zig will complain, right? Yeah, Zig complains. Okay, the tools don't complain. I don't know why they don't complain. Like, the Visual Studio Code comes with its own C tools that I guess don't complain even in obviously deeply bugged situations. So we've got at least one other call to that. We can just get rid of that here. And now we notice that the things that we need to store in the body have decreased. There's no real reason to keep offset X. We'll get rid of that. And for some reason, when you structure your programs like this, it just gets really easy to delete things. Like it becomes a lot easier to get rid of them. Let's one of the easiest ways to get a window is to hit Alt Tab. As you can see, Alt Tab will just jitter it, and we can we can try with our mouse. We can try to pick it up, and can we grab this window? Can we? That's hard to time this, isn't it? Yeah, let's see. We got a head start. We could grab this window, I'm telling you. We'll make this big. Well, that's the trick, isn't it? We'll get it over there. Oh, I clicked too fast. There, now, oh, look, oh, that breaks everything. Wow, that creates a real mess. Yeah, we can maybe be satisfied that our program does not work any worse than before. Now, if there's a lesson to take away from this, I'm not sure. I think that there are a lot of reasons not to use C, the programming language, and I'm relieved to point out that these patterns that I've been praising, without adequately explaining how they work, are also possible in Zig and possible in Rust. I would say that, like, this is extremely fraught code. In my first implementation of this, there were a lot of bugs that were just caused by me using size of the wrong type without me recognizing it. And Zig didn't complain, and Visual Studio Code didn't complain, and I find that frustrating. I think that, as before, I'm going to make the code for this project available on my Git server, or rather the Git server that I share with a friend. You can take a look at it, and maybe you'll find some things to do with it that I didn't find. I would recommend giving both a try, but I think that for serious programs in the category that you would normally use Rust for, or sorry, normally use C for, you should probably use either Rust or Zig, depending on what your personal preferences are. They're both decent, and you might find that the improved error messages make a lot of difference to you. I think that that's all I have to say about this program. You can do what you will with it. I'll sign out now. Well, I will when I find OBS. Is this OBS? Yes. You can't see it, but I can see it just fine. Goodbye.